Hello all. In this video, we will learn the concept of canonical cover, minimal cover, and irreducible set of the functional dependency set. It means how to find out the irreducible set from the given functional dependencies. So, let me give you a brief about the topic. Means what it means to find a minimal cover, or what it means to find a reducible set from the given functional dependency set. So suppose a functional dependency set which is given is, suppose f is a set which contains functional dependencies as a tends to b tends to c, and c tends to a. Now you can see that in this set we have a functional dependencies which derive b from a, and functional dependencies which derive c from b. Now the a can further be derived by c. So because this third functional dependency can be understood or can be derived by these two functional dependencies by the property of transitivity. So this functional dependency is extra, or by removing these functional dependencies from my functional dependencies set, does not affect any important uh, does not affect my relation schema as much. So this may be treated as a redundant functional dependencies for my functional dependence set, and I can remove these functional dependencies which does not affect much, or which does not affect at all to my relation schema R. So in canonical cover or minimal cover or reducible set, we need to find out these type of functional dependencies which are redundant in the given set. Along with this, we need to eliminate the extraneous attributes. So to find out the irreducible set, two things are there. First thing is removal of redundant functional dependency. Second is removal of extraneous attribute. Removal of extraneous attributes. So what are the extraneous attributes? Those attributes those attributes those attributes which are not useful, which are not useful in functional dependencies set. So to eliminate the redundant functional dependencies from the given set, we need to check for the closure of the RHS side of the functional dependencies, and if we found the another functional dependencies from the closure, then that thing may be a redundant thing. So we will understand this concept by the example. So let me brief about the steps which is to be taken in order to find out the minimal cover. So for any set of functional dependencies, first step would be first step would be eliminate sorry the first step would be union simplification. So union simplification says that union simplification means if any functional dependencies like A tends to B is given, then you need to simplify this functional dependencies like this. Now, after union simplification, step 2 is remove the redundant functional dependency set. Then step 3 would be removal of extraneous attributes, or we can say that LHS simplification, because generally we find the extraneous attribute at LHS side which does not contribute in the derivation of RHS side. So LHS simplification or removal of extraneous attribute. Then step 4, so if we found any extraneous attribute, then so I write here, if step 3 is success, then repeat step 2. So because the functional dependencies changes, so it may possible that redundant functional dependencies may occur. Otherwise go to step 5. So step 5 says that apply union. So this apply union property means, so if any functional dependencies like A tends to B, C and A tends to D is given, then you can write here like A tends to CD. So you can combine with the property of union. So this is sorry for spell. Step 5 contain apply union. So this type of two functional dependencies can be combined into one functional dependency in order to reduce the set of functional dependencies. Okay, now let me cover this whole step in a example. So let's take an example. So let's take an example to find out the irreducible set from this given set of functional dependencies. So in this set, these functional dependencies are given. So we we number the functional dependencies as 4 equations. So let's take a step 1. Step 1 is a union simplification. So union simplification only applies when the RHS side of the functional dependencies contains more than one attribute. So because all attributes at RHS side contain only one attribute, it is not more than one. So union simplification is not required. So here union simplification is not required. Now step 2 would be identify the redundant functional dependencies set, and we have to check for one by one for the redundant functional dependencies set. So for first one, we need to check for this functional dependency set whether it is redundant. So if we need to check this one, we need to hide this functional dependencies and calculate the closure of A, B, C, D from the equation 2, 3 and 4. So by hiding 1, we need to calculate the closure from 2, 3, 4. So this ABCD closure gives you attribute A, B, C, D. Along with that, from 2, 3, 4, whether you can drive another attribute, yes. From third you can drive D, but it is already there. From second you cannot drive anything, and from fourth, yes, you can drive B, which is already there. So this is the attribute. These are the attributes which can be derived. In these attribute you cannot find out E. So the first functional dependency is not redundant. Second, check for the equation 2, where you need to find out the E closure from equation 1, 3 and 4. So E closure would be E. From equation 1 you cannot find out anything, even in equation 3 you cannot find out anything, and from equation 4 also you cannot find out anything. So these three equations cannot find any other attribute, so E closure will only lead to E. So this functional dependency is also not redundant. So this is important functional dependencies for my relation. So no functional dependencies will give you D. In third case, you hide equation number 3 and find out the AC closure from equation 1, 2 and 4 and check whether these can derive the attribute D. So AC closure will give you A, C from AC closure will give you AC. From equation 1 you can derive anything? No. From equation 2 nothing can be derived. From equation 3 you can derive B, because A can derive B. So ACB can be derived, but D cannot be derived. So this is also a unique functional dependency. Fourth functional dependency is A tends to B. You need to find out the A closure from 1, 2, 3 and check whether the B can be derived from these three FDs. So A closure gives you A. From first equation you cannot derive anything. From second equation also you cannot derive anything, and for third equation also you cannot derive anything. So it will not lead to B. So this is also a unique functional dependency. So in second step all functional dependencies are unique. That's why go to step 3. So I remove this step now and just jump to step 3. So now in step 3 we need to remove the extraneous attribute. So or this step is also called LHS simplification. So in LHS simplification we need to remove the extraneous attributes. So for each functional dependencies we have to check whether this functional dependencies contain any extraneous attributes or not. So for first one, A, B, C, D, which derives E, we need to check whether any attribute is extraneous. So to check whether attribute is extraneous or not, what we do, we just remove one attribute from here. So suppose for this functional dependencies, first I remove A from this functional dependency and calculate BCD closure from equation 2, 3 and 4, and if we found out A in BCD closure, then we can say that A is a redundant attribute. So in BCD closure we found only BCD, nothing else, so we can conclude that A is not redundant. A is not redundant. Similarly, in next iteration for the same functional dependency a b c d tends to e, we remove b from this functional dependency and calculate ACD closure from equation 234. So when you calculate ACD closure, you can find out A, C, D, and from A you can find out B. So ACDB can be found. So in this one you can find B. So when you find B, it means you can conclude that B is redundant because from ACD closure and from equation 234 you can find the attribute which is removed in your functional LHS side of the functional dependency. So B is redundant here. Similarly, check for the C removal. So you remove C from the given functional dependency set and calculate A, B, D closure from the equation number 2, 3, 4. Then the ABD closure gives you uh, sorry once any redundant attribute is found, then it is actually unnecessary to have the B attribute again in order to calculate the further uh, extraneous attribute. So after you find the redundant attribute, we need to remove this attribute from the given functional dependency. Now functional dependencies will now reduce to the updated one, and we have the functional dependencies as A, C, D, which lead to E after this step. Now again check for A, C, D to E by removing C from this functional dependency on LHS side. Check whether the AD closure will give you C when applying or when finding the AD closure from 234. So when we find the AD closure from 234, we will get the A, D, B, but we will not get the C attributes. That's why C is not redundant. Then finally, from the same A, C, D tends to E, now we need to find out the AC closure by removing the D attribute and find the AC closure from 2, 3, 4. We will get the check for whether we will get D or not. So from AC closure we will check that we will derive AC, and from AC we can derive D, and from A we can also derive B. So yes, from AC closure we can derive D, so D is redundant. So those attributes which are redundant are called extraneous attributes in the functional dependencies. Here D is redundant, it means you can remove the D from the functional dependency set, and the reduced functional dependencies would be AC tends to E. Now this functional dependency would be the updated one. Now step 3 again will apply on the second functional dependency is that is our E tends to D, but the LHS simplification is only applied to those functional dependencies in which the LHS side contains more than one attribute. So we will not apply this LHS simplification on second and fourth FD. We will apply the LHS simplification on the third FD, that is AC closer. Sorry, AC tends to D. So in this AC tends to D, when we apply the LHS simplification, what we got, I will write here. So AC tends to D. To find the extraneous attribute in this functional dependencies, we will hide the A from this functional dependencies and find the C closer from the equation 1, 2 and 4, and look for the A in the C closer. So C closer will be C only. There is nothing like another attribute cannot be derived from this C, from equation 1, 2 and 4. So we can say that A is not extraneous. Similarly, we have to find out the A closer by removing C in this functional dependencies and find the A closer from 1 to 4. We find that A would be derived, and from fourth equation we derive B also. That's it. So we cannot derive C, that's why C is not extraneous. So in this functional dependencies we cannot find any extraneous attribute, so this functionality remains the same. So here step 3 will be completed, in which one functional dependency is modified, and if in step 4 if any success we got in step 3, then we have to repeat the step 2. So the modified functional dependency set would be I will just rough it again. So let's make it rough here, because you already know the steps, so I just rough it. Okay, now so step 3 will complete now, because step 3, after step 3 we have the functional dependencies as AC tends to E, that is the first functional dependency. Second one is E tends to D, that is second functional dependency. Third one is AC tends to D, in which we cannot find any extraneous attribute, and A tends to B, that is fourth one. So this functional dependency is reduced. That's why step 3 will lead to in success. Now if we have a success in step 2, we need to repeat a step. Sorry, if we have a success in step 3, we need to repeat step 2, means we need to find out the redundant functional dependencies in these 4 sets. And in order to find out the redundant functional dependencies, we compute the same procedure again. So first is we need to hide this AC tends to E and try to find out the AC closer from equation number 2, 3, 4, and find out that whether we got E from this AC closer. So when you find out the AC closer from equation number 2, 3, 4, we got AC, D and B, but we cannot find out the E, so this is important. So this functional dependency is not redundant. Similarly, we in second step we find out E closer from equation 1, 3, 4. So we hide equation number 2 and find out the D. So E closer will lead to E only, and we cannot derive anything, so this is not redundant. Equation number 3, we need to find out the AC closer. We need to find out the AC closer from equation 1, 2 4 and look for the variable d, whether they derive d. So AC closure will lead to AC, and AC will lead to E, and E will lead to D, and A will also lead to B. So your AC closure can find the variable D from equation 1 to 4. So this will lead to the conclusion that AC tends to D is redundant. Now check for the last one. A tends to B, so we need to find out the A closure from equation 1 to 3 and find out whether they derive B. So A closure will lead to A, and this equation number 1, 2 and 3 cannot give B. So your A closure cannot be redundant, just only give A. So this cannot be redundant. So this is right functional dependency, this is redundant, and this is right functional dependencies. So after step 2, the final irreducible set is this irreducible set, that is AC tends to E, that is first functional dependency in which there is no extraneous attribute, and this is not redundant functional dependency. Second is E tends to D, and the third is A tends to B. So this is the irreducible set for the given functional dependencies. Thank you very much for watching. In next video we will cover the SQL queries concept based on the database management system. Thank you very much for watching.